So in today's session, we are going to see some of the insights as far as deep feed forward networks are concerned. Uh, Before we go ahead, we need to know regarding the basic deep learning models and what is deep learning, why we need to go ahead with deep learning models. Mainly when compared to the machine learning approaches and deep learning approaches, we have some of the insights that differ from machine learning and deep learning. We are going to have some sort of neural network structure in deep learning when compared to the machine learning approaches. In this, we are going to have the detailed analysis of all the feature extractions, and we are going to design the models based on the feature extractions that we have obtained. Basically, as far as deep learning models are concerned. So, in today's session, we are going to see some of the insights as far as deep learning models are concerned. In these deep learning models, we have one important aspect, that is the feed-forward networking structure. So in this, we have one input layer and we have some sort of hidden layers in between, and we are going to pass on the data with the output layer. So the thing by the name feed forward, we are going to have a forward structure by taking the input data and passing over all the hidden layers and obtaining the finalist outcome of the data according to the solutions are designed. So let us just see what are the basic insights that are available in the deep feed forward network structure. So basically, as far as deep learning and artificial intelligence models are concerned, we have several sort of networking aspects, mainly the neural network structure construction that takes place in the deep learning architecture. So mainly this architecture is based on several set of layers, as we have discussed in the earlier image. We have seen in the earlier image, we have various layers passing over from the input layer to the output layer. What is the basic difference between the generalized conventional programming and neural network deep learning and AI related programming is that we have some sort of inputs, we have outputs. We are supposed to design the entire process that takes place in between the input and output area. So this is the major challenging task as far as AI structural designs are concerned or AI related applications are concerned. So we have some couple of applications as far as deep learning neural network architecture is concerned. We have image processing related aspects and voice recognition related aspects, NLP based forecasting applications, and some sort of recommended systems are going to use the deep learning models mainly to enhance the progression of inputs and outputs. To enrich the dataset of the predictions, we are going ahead with regard to the deep learning models. So the major thing is that we generally use to classify the data and regression of the data, nothing but one sort of predictions that we takes place as far as regression model is concerned. So the feed forward network is one of the network that consists of multi-layer perceptron architecture, which is called as MLP architecture. We have some couple of perceptrons. So a perceptron is nothing but one sort of element in the networking brain that is going to percept all the data information. That means which is going to see and view all the data. That means the aspect of perception. So this relates to the perception that takes place in the multi-perceptron neural networking architecture. So it consists of mainly the input layer, which is the raw inputs that are to be attained to that particular layer is concerned. We have some sort of hidden layers. These are nothing but one sort of deep learning models that we have attained. So the things that we perceive with some sort of weights that are to be upgraded with all the layers, passing on all the layers and reach the outcomes according to the percepts that we have. Like we have some sort of visions, we have some sort of missions. The ultimate aim of deep learning model is that to make the vision into a mission. So this is the major thing that takes place as far as deep learning model is concerned. So we are going to pass many sort of hidden layers over there and getting up the output information from the input that we have transmitted. So information is going to move forward from the input to all the hidden layers, passing on to the output. So here we are not going to use any sort of back propagation path or back propagation related predictions that takes place. So that's why it is called as feed forward networking structure. So this is the structure that depends the perceptrons or the views that pass on to all the hidden layers to be updated as far as the output layer is concerned. And these are added to some sort of weights with the help of functions called as activation functions that takes place in between the hidden layers or the hidden nodes that takes place and passing on to the output layer. So this is the structure. The basic outlayer is that we have the input layer. It is going to receive all the raw information. Suppose we are going to transmit 3 or more images. These 3 images are being trained in the input layer, and these 3 layers are going to pass to the hidden layers, all the hidden layers, and making up into deep description of all the feature extraction and feature processing that takes place with the help of some basic patterns in the first layer and digging on all the deeper features in the middle layers. And along with these two, the third layer is going to come up with the abstract concept or the abstract features. And finally, we are going to get the output image. For suppose we are having the image of cat. So cat, it looks like some sort of features of cat are to be extracted first to see that it is going to identify the cat, particularly cat or dog. So these features are going to differ. Like the voice might get differ from cat and dog. There is some sort of variation. So that feature is to be extracted, and the voice is to be recognized. That means the voice of cat is to be recognized by the system so that it is going to train on its own. So this feature of the voice is going to get extracted. That depends with the classification or the regression principles that we used to do as far as the output layer is concerned. Now we are going to use some sort of regression techniques like price or scorecard and other things. So these are mainly for classification to recognize cat, dog, and car and other things, other sort of objects that we are going to train. Based on that, we are going to take a decision accordingly. We have using some sort of multiple neural network structure, multiple inputs. By adding some weights, we have added with some sort of bias functions. We have some sort of activation functions that lies as far as neural networking structure is concerned. We'll look forward regarding all these concepts in future. So all the things are going to pass forward. And if we want to make the learning ahead or a part, we need to have the comparison analysis. That means we are going to use the actual predicted data with the actual answer. Suppose I have trained all the 3 images to convert an image into a cat. So this has to be compared to the real cat. So whether these two are mapping each other, then we can get the correct answer and we have less error rates. And if we do not have all these things, we do not get good answer. That means the error is going to get high and bias and variance are going to vary between the actual image and the predicted image. So the weights are to be adjusted first. So this takes place in the gradient descendant boosting algorithm that we'll discuss in the next upcoming sessions. So we are going to repeat with same example all the aspects that deals with the back propagation algorithm. This is the most important algorithm that we use mainly as far as deep learning models are concerned. So now compared to the deep learning models, why deep learning is more important? We are going to classify the data based on the images. There is some sort of speech recognition that takes place in as far as deep learning models are concerned. Fraud detection that might be detected with higher accuracy when compared to deep learning models. The major thing is that whenever we are going to train any sort of data set with machine learning model and deep learning model, we can have all the feature related properties extractions in a deeper manner. That's why it's called as deep learning. The features are identified with all the deepest operations that takes place. So that's why it is called as deep learning. So when compared to the machine learning models, deep learning models, we have some extra sort of features that might give better accuracy when compared to the machine learning models. And we can use it in medical diagnosis, that we can define it. We can have some sort of usage in the recommendation systems. So these are some of the things that we discuss as far as deep learning models or deep feed forward networking structure is concerned. Now, when compared to the summary of all the things, forward is nothing but we are going to take the information to move forward. We are going to extract all the features from all the layers, from one layer to the other layer. So that is more than one hidden layer. We are going to attain all the things. We have neuron for computing, basic computing unit as a neuron. We have weights as strength of connections. We are going to use the bias as the adjusting term. We are using activation functions, which are non-linear representations of the deep learning architectures. We have forward pass, which is going to generate the prediction based on the certain analysis. We have back propagation to correct some sort of learnings that takes place. And gradient descendant boosting that deserves with the learning process. So these are the basic outline of deep learning neural networks. So now compared to, let's just go ahead with some sort of storyline to have an analysis of complete structure as far as deep feed forward networking structure is concerned. So let's just move ahead with a small storyline. So the story, it deals with the concept of case of the silent clock. The tagline of the story is the silent clock that takes place. So let's just imagine there is a city, and in the city, all the people are going to work based on a single clock. There is one single clock in that particular city, and all the people are going to work, going to do their works based on the clock time that is available in that particular city. So in this gesture, if there is any sort of issue as far as the clock is concerned, all the people are going to start or stop working. That means the people are directly proportional to the time period that is available in the clock. So in this gesture, if the clock stops, the people will stop working. So this is the general strategy that takes place in that particular city. So on a fine day, the clock stopped working. What happens is not known to all the people that are available in that particular city. So now people need someone to investigate what defect had happened in that particular clock so that it can be corrected forward, and people can work together as far as the process is concerned. So now in this basic investigation process, we need to take some raw inputs. So what are the inputs that we are going to train? People, whoever met with that particular clock or gone on that particular room, are to be identified first. So how can we identify them? So we are going to take all the inputs as raw inputs, like the footprints that takes place in that particular clock. So whoever have gone on that particular day to that particular clock before the stop time, those are to be judged first, that to be investigated first. And there are certain clues that are available in that particular clock period. So a broken gear was there. So this is one of the most important element that is available in that particular clock rate is concerned. So there is one broken gear and there is one piece of cloth that is available in that particular clock tower is concerned. So we have one suspicious footage of CCTV. So through this CCTV, we are supposed to train all the three things so that we can recognize that culprit who have damaged that particular clock, so that time period is not going to run accordingly. So this is the major collection that takes place in the raw information. So we are going to take all the raw inputs with all the three elements. That means all the footprints are to be trained, a broken gear has to be trained, and a piece of clock has to be trained by identifying a shadow on the CCTV. So all the three images are to be taken up as inputs in this particular analogy. So we are going to take all these three things as inputs and we are going to training up the data. So now the actual training takes place. That means we are moving ahead towards the investigation of the process where the clock has stopped. That means the investigation takes place with the help of all the hidden layers. So we are going to take to that first investigation process that takes place in this particular tower is concerned. So first, based on the footprints, we need to recap the features of size and direction of the travel of those footprints and gear, how forcefully the gear has been stopped and what is the material and colors, these to be trained first, and shape of the shadow is to be trained first. So that means what, in the first layer, we are going to extract all the features. That means all the feature engineering that relates to the case is concerned. These are trained first in the first investigation room. So now we need to clean up all the information. We have taken up all the information. We have taken up all the images like size, direction, force, material, and other things. Now, coming to the second investigation synergy, there are some sort of questions that takes place when compared to these features are concerned. We need to map all the features with the extracted features that takes place in the room. So that means are the footprints on clock are from the same person or not? We need to identify that. Does the broken gear suggest some sabotage or not? This to be identified first. And what matches the shadow? That means we are going to take all the patterns that occurs in the first investigation and we are going to mapping up all the patterns with the other investigation that takes place in the second investigation. That means in the second hidden layer, we are going to investigate all the case with all these sort of instructions. So whether the footprints belong to male or female, this to be identified first. So these are to be trained with the help of the model that we are going to do in the second process. So cloth, so which cloth it belongs to? It belongs to some sort of worker in the maintenance room or some other person that might take place. So gear, it is going to cut intentionally or someone has broken it, that to be identified first. So this is the second investigation process that takes place in the second layer. Now coming to the third layer, we need to have the quite amount of investigation that takes place from the two things. So mapping up and the actual images are going to map with the images that we have. That is to be identified first. So we can have some sort of stories based on the instructions that takes place in the first layer and the second layer. That means if someone has distinguished as a maintenance worker, probably these things will take place with the help of the maintenance. when there is any sort of maintenance issue, the clock may get stopped accordingly. So based on the primary investigation process, mostly it might takes place by a maintenance worker. A maintenance worker may get damage this particular clock. That has to be recognized first. Probably there is a chance based on the investigation from the first and second layers that we have taken up. He might have cut the clock, cut the year to stop the clock and recognize the symbolic timetable, symbolic time, so that people will stop working on that particular area. And there is one more case in this particular gesture. There might be a common man who might get damaged in this particular clock so that people will stop working. So if a person have some sort of jealousy or issues with regard to the other person, he might have stopped this particular clock so that people will stop working. So this is the second synergy or the second prediction that occurs as far as this particular tagline is concerned. So what does the sparrow he exited on that particular river is concerned, that has to be identified in the next theme. So when compared to all the three synergies, pattern 1 and pattern 2, so in the pattern 1, we are going to take some sort of inputs. We are going to take all the footprints and broken gears and other images, and we are going to turning up as the inputs with the help of the with the help of the CCTV footage that is available. In the second issue, we are going to taking up all the features like size, direction, and other things. Now in the third phase, we are going to taking up all the patterns and mapping up all the patterns. And in the third hidden layer, we are going to derive some sort of interventions from all the 1 and 2 layers that are hidden. So in the first layer, we have extracted all the features. In the second layer, we have mapped with some sort of patterns. In the third layer, we are going to come with some sort of conclusions based on the things that we have attained with the features and the patterns. Both are to be mapped in the third layer. So in this third layer, we are going to interpret who is the culprit. That is to be judged first. Most probably, with the conclusions or with the interventions that we have, the maintenance guy who is available in that particular row may get damaged this particular clock, because most of the people, we can have the timeline or the tagline to have the investigation process. With this timeline, we can judge that the person who is mostly available in that particular clock room may get damaged the clock. Else, no one is going to damage other people properties. So this is the interpretation that we takes place in the third layer or the third hidden layer. So finally, we can have a conclusion that the guy who has doing the maintenance work may cut the gear and stop the clock, and he is going to escape towards the river, so that we can predict that he is one of the culprit that who is going to hidden the clock. So with these three predictions, we came to a conclusion that the guy who has stopped the clock is the guy who is in the maintenance room. So the learning process that takes place based on the patterns and the time period and all the work, we came to a conclusion that the output layer, we came to a conclusion that the guy who has stopped the clock is the guy who is working in the maintenance room. So this is the final conclusion or the final prediction that we can have based on the layers that we have gone through. From the input layer to all the hidden layers, we came up to the conclusion that the guy who has cut the gear and escaped from the river is the guy who is in the maintenance room. So this is the final conclusion that we have. based on the predictions that we have. But what actually happens is that we need to have the property of back propagation learning to find out the actual result from the predicted result. This is the major thing that takes place in the machine learning algorithms or deep learning algorithms. Mainly as far as AI is concerned and neural networks are concerned, we are supposed to do some sort of back propagation synergy to deserve the actual outcome to the exact outcome that is to be identified first. So here the twist comes. So we came to the conclusion that the guy who is going to work more apart in that particular room is going to damage the clock and he went away. So, but when we back propagate with the results that takes place, we came to the assurance that we have the motivation too quickly. That means the decision that was predicted was exactly wrong. As I said, we have two cases in this particular gesture. One is the guy who is working in that particular maintenance room may damage the clock, or the guy, a common guy who is moving ahead, will have some sort of jealousy related issues or some sort of angers on the particular guys in that particular village is concerned. He is going to damage the clock. He might get damaged the clock. Now, when we come across all the three synergies, all the three themes, we have assumed that we can have the motivation too quickly based on the predictions that we have. We came up with the assumption that the motive is that we need to predict to the culprit guy. So the culprit guy is going to get predicted based on the assumptions and the learning algorithms that we have attended. But the prioritization is to be identified first. That means the reality is different from the exact conclusions that takes place during the machine learning assumptions. So here the reality is that a common guy who is moving ahead on that learning room, has damaged the clock. But we came up to a conclusion that the guy who is doing the maintenance work is going to damage the clock because he has the technical identities. So this is the wrong assumption that we have concluded. So we need to back propagate with regard to all the realistic data, go with all the clues, have the analysis of all the clues once again. We need to recheck with all the materials. Suppose here we can come to a conclusion with the cloth material that we have. So this to be identified with the DNA pattern on that particular person to recognize that this guy has damaged this particular clock. So this is the major thing that happens. That means we came to a conclusion, but the learning is not exact. We do not have exact learning. We have some damage related learning that takes place. But the learning that is predicted is far apart from the learning from the actual. So this can be identified with the back propagation algorithm to recognize that this aspect is going to map with the realistic thing. So here the reality is that the guy who is going to work in that particular clock is going to damage that particular clock. So who is a common guy is going to damage that particular clock. So the culprit is a street performer who is going to climb up the tower in the night and accidentally he got damaged the gear and clock. So this is the reality, and we came up to a reality that we came up to a prediction that the maintenance guy is going to damage the clock. So this is the basic difference between exact thing and the real thing. So that's why we need to use the back propagation algorithm to check with all the mistakes that happens that might come across during the predictions. So those are to be overcome with the learning principles. And finally, we have resolved the problem that the tower is going to save, and the defective system has learned with all the mechanisms that we have attained, and the street performer who is going to climbing up the tower accidentally has damaged the clock. Now the clock has been set, and the street performer is identified as a culprit in this particular investigation process. So in this way, we can narrate all the entire things, all the entire features. So the primary thing is that we are going to learn the basic deep feed forward networks. By taking up the inputs, we have taken up the inputs as all the three things. That means footprints, broken gear, and the piece of cloth. So these are taken up as the inputs in this particular area. So now coming to the hidden layer, we are going to extract all the basic features. The basic features that we have extracted is that we have footprints with the help of size and direction. We have gear with size of force. We have cloth with material and color. We have the CCTV footage, that means shadow of that particular person. So these are the coming up in the basic feature extractions in the second layer. Now coming to the hidden layer 2, we are going to combine all the features. So with the help of features, we are going to design some sort of patterns. Whether the footprints are male or female, whether the cloth is maintenance room or other cloth that takes place, other people who is going to work out there, whether the gear has cut intentionally or gear has some sort of issues, technical issues to have the brokerage. That is to be identified in the second layer, second hidden layer 2. Now coming to the hidden layer 3, we are going to come up with some sort of conclusions. That means we are going to mapping up the patterns, and we are going to taking up all the conclusions with these features. In the fourth layer, we are going to come with some sort of predictions. And if there are some sort of issues in the learning that takes place, we are going to use the back propagation algorithm, and we are going to recognize the errors, and we are going to existing up all the logics with the help of gradient descendant algorithm. So this is the major theme that takes place as far as the higher story tagline is concerned. Okay, so with this, I'll be concluding up the session for today. If there are